Hello, everyone. It is my pleasure to be the keynote speaker for this conference, and I'm happy to be talking about generative AI, which has caught the public imagination in the last 1 or so years. And I particularly like to focus on human psychology and how we can forge a path toward more socially responsible trust by understanding human psychology and how human psychology responds to AI. So in this talk today, I'd like to first provide an introduction to AI and talk about how we think about AI in terms of media and also in communication terms, and provide you some conceptual background with which to understand it. I'll also be talking about biases in AI technology and also biases in human psychology. And then finally, I'll wrap up by talking about different socially responsible ways of building, employing, and using AI. To start with, I think it's important for us to think about the role of AI in human communication, the role of AI in our midst. So my colleague Unju Lee and I came up with what we call the 4C framework in a recent article that was published in Human Communication Research, which is a journal of the International Communication Association. And there we organized it in terms of mass communication and interpersonal communication, the role of AI in mass communication and the role of AI in interpersonal communication. And we also differentiated between AI as a communicator and AI as a mediator. So when you think about it, an AI creator, which is really what a lot of us are talking about when we say there's a virtual agent, a virtual influencer, or an AI anchor for news, they are basically communicating to a lot of people. That's mass communication, and they are generating the communications themselves. Analogously, when you're talking about things like smart speakers or chatbots or virtual assistants, we are talking about AI as a converser. It's a conversation agent, and that's typically interpersonal communication. It's one-on-one. The AI system is talking to you as an individual. You also have AI in the mass communication context as a curator. So those of us who watch Netflix, we know that a lot of the movies that are recommended to us are curated based on our prior viewing habits and also the recommendations of others. And also that's true with content recommendation systems, e-commerce recommendation systems, and so forth, all of which help AI to curate the content for us to view. And then finally, AI as co-author is where in interpersonal context, when we are sending a message to somebody else, you get AI's help, and the AI can mediate interpersonal communication. So for example, on applications like Gmail, you start to type out an email, and then automatically the AI behind the scenes is filling out your sentences, filling out your thoughts. And this is what we refer to as autocomplete. And in fact, this is the technology underlying, in many ways, the large language models that are the key to generative AI. There are neural networks which process natural language, and then they in turn are able to generate content, predict what might be the content that we have in mind, and that's why they're able to complete our sentences. Used to be they would only complete our, the last few letters of words, and then they became sentences, and then onto phrases, passages, paragraphs, and they now compose entire, books, if you will. And so generative AI has really advanced in technology. It can help us, write emails, write entire stories, news stories, lyrics of songs, summarize articles and books for us. You can ask it to kind of digest an entire volume and give us a a succinct summary. It can explain concepts to us in more detail, just like a teacher does. It can create computer codes. It can have social conversations with us as if it's another human. And it can certainly solve problems, troubleshoot with us, and many, many more applications. Day in and day out, you see all these different, chat GPT hacks, if you will, that are coming out that help us prompt these generative AI tools in ways that can maximize the utility of these tools for us. Alongside, there is a growing concern about ethical issues related to AI, driven by the rapid advancement of generative AI technology and the associated risks of misuse and security threats has really made people, including industry leaders, ask and call for more regulation, more guardrails, if you will, around AI technology. And so it's important for us to think in terms of policies that can help rein in this technology, but without curbing the innovation, without curbing all the good things that can come out of this technology. So one of the long-standing problems with AI is the black box issue. I'm sure you're all aware that when the way the AI black box works is you feed some training data into this AI so that the AI can learn. So this is the classic machine learning example where there's an algorithm that learns how the data are structured, and then you feed new data and ask it to predict the outcome. And based on how it learned from the training data, it'll predict outcomes. So this has been used in a number of different domains, as you can imagine. But unfortunately, we have very little understanding of how it determines, how it makes those predictions. So a classic example of problems with this or concerns raised by black box nature is the gender classification AI that came out a few years ago. There was a study out of MIT that basically is evaluated or audited different technologies, different AI recognition technologies that were tasked with recognizing the gender of a person. And they found, to their amazement, that it was pretty accurate when it came to recognizing the gender of whites. You can see that the accuracy was very high for lighter colored males and females. For lighter males, the Microsoft gender recognition tool was 100% accurate. And for lighter females, it was almost there in the high 90% range. And that was true for other tools from other companies as well. But when you look at darker shade people, darker men were lesser, it was less accurate in recognizing the gender of darker men. And it was very bad when it came to recognizing the gender of darker females. So this is what we call intersectional inaccuracy. Dark females have two knocks against them. Not only are they dark-skinned, but they're also the female gender. So putting them together creates a kind of a multiplication, if you will, of the bias, and therefore they're even more biased. And the reason why these tools do so badly in recognizing the gender of Black females is because they are trained with a data set that is primarily white. This is a snapshot of the labeled faces in the wild data set, which is known to have over 77% males and over 80% lighter skin color individuals. And no wonder when you feed this into the algorithm, when you feed this into the black box, it comes out with results like this, where it's accurate for white faces, but quite inaccurate for dark and especially for darker females. And so this kind of biases have started to come out in a number of different domains. There was a famous example of Google image recognition software a few years ago, which automatically grouped Black people as gorillas. And so this, of course, created a lot of controversy and a lot of social media posts, making Google pull it down immediately. But that kind of a bias, happens because the black box is in some ways unexplainable, uninterpretable, and this is now carried over to large language models. There was a study out that came out 2 years ago, even before ChatGPT, where a bunch of researchers prompted GPT-3 to complete a sentence that starts with two Muslims walked into a, and then you could see all the responses that it provided: a synagogue with access and a bomb, a gay bar and began throwing chairs, or it opened fire, they opened fire, they started shooting at will. These kinds of negative association of Muslims with violence is because it has been fed with training data, or it has consumed training data that primarily associates Muslims with violence. And so there's a clear bias here, a racial bias, an ethnic bias, a religious bias that is baked into the algorithm. More recently, there was an expose by Bloomberg of stable diffusion, which is an image generating tool. So this is an example of generative AI that produces images. And so stable diffusion was used by Bloomberg to produce images of people in different professions. And then they got about 5,000 images and coded those images for the skin color of the images it produced, of the faces that it produced. And they found that for high-paying professions like architect and lawyer and CEO and so forth, most of the images it produced, the vast majority of images it produced, were white skin. There are very few dark-skinned individuals that, faces that it produced for these high-paying professions. But the reverse was true for low-paying professions, like fast food worker or social worker. For these professions, you can see the minority is light-skinned and the majority is darker-skinned individuals or faces that it produced. And this was true even for gender. You can see that for high-paying professions like engineer and judge and CEO, the vast majority of the images were that of men. The darker shade here, the darker green, is all male images. And you can see minority is lighter, the females. The lighter green images, they are females. And so you can see that this is not only skin color biased, but also biased in terms of gender. Again, you see housekeeper, pretty much 100% of the images it produced for housekeeper and also for social worker were females rather than males. So you can think about this as a kind of an exercise, and they have a nice tool on their website, which you can see, give me a color photograph of an architect, and you'll see mostly white males in, formal suit, or cashier, you can see mostly dark-skinned people. Or if you ask for a CEO, you see white males in suits. If you ask for a dishwasher, you see mostly dark and mostly women. Doctor, mostly white again, a few brown color faces. So in this way, you can see that it's biased. And so this kind of bias is being exposed by tools like this. And, they can cause all kinds of harms. There are very many, harms from algorithmic decision-making that has been documented by several, watchdog groups, if you will. And you can see There are individual harms when it comes to hiring, employment, insurance and social benefits, housing and education. This is a loss of opportunity that people face. People with dark skin may not get credit for starting businesses or for home loans and things like that. So you have economic loss. You also have social stigmatization, where there's a loss of liberty. Police are known to have increased surveillance of darker skinned individuals. And some of these tools can reinforce stereotypes, and they can cause dignitary harms, all of which end up socially stigmatizing people based on their skin color, based on their gender. And in particular, social detriments can be particularly subtle and not noticeable, and also, sort of in the background and cumulative. In the media world, we particularly worry about social detriments caused by things like network bubble, where your exposure to information or to opportunities is highly dictated by who you know, or filter bubbles, where everything that you get is filtered through, by algorithms, through your own familiar patterns of prior behavior. There are different kinds of confirmation bias that are in play. And so these kinds of things can be very harmful because they reinforce stereotypes, they limit your worldview, and they can also lead to all kinds of bad decision making. They can also lead to loss of liberty because you are more likely to be held in suspicion. If you're dark-skinned, you're more likely to be incarcerated. You're not likely to be given parole. And so there's going to be disproportionate harm that's caused to you compared to a person of a lighter skin. And in the media world, we worry about these kinds of algorithms also creating misinformation, and misinformation at scale. We've already now lived through 2 election cycles where there have been all kinds of misinformation spread about candidates, about fake news that are not really generated by people, but generated by tools, bots that are floating about on our social media platforms. And with generative AI, especially image generative AI, it can be even more dangerous because it can create images that never existed and make it look like these images existed. It's almost like, it's very hard to tell fake from reality. And this is especially bothersome with deepfakes, which not only talk about images, but they're talking about they are faking videos here. And so you can take somebody else's voice and make it look like Tom Cruise is saying it. And the same is true with this example, which is a very famous example of a comedian, a famous US comedian, pretty much putting words in the mouth of Barack Obama, the president. And, it is very hard to tell that it was not Barack Obama who said the same things. And these kinds of things are, shown on media and sent on social media as memes sometimes for fun. And people talk about it as amusement, but they can also have deadly consequences. So one of the things that I was really concerned about is in my own country, in my own native country, India, the so-called WhatsApp murders, where false videos that went viral on WhatsApp, which is a messaging service similar to Kakao Talk, where it's being circulated among family and friends. These videos created actually fearful mobs that killed dozens of innocent people. So here's a little example of a video that shows how a doctored video can have deadly consequences.
2 men on a motorbike apparently snatch a young child off the street in a video that has spread a dangerous panic in India. In fact, this footage was filmed in this street in Karachi, Pakistan, not in India. And the full video makes clear this was not a real kidnapping, but an advert designed to promote child safety. The version spread on social media has this ending edited out. In India, at least 8 people have been killed in a spate of lynchings. Mob anger fueled by this and other fake news. So this was where you filmed the video? This Karachi advertising company made the video. They're horrified at how it's being used in India.
I mean, this is, is very devastating for me. It's very shocking for me. I don't have words. I mean, I just want to, I told you earlier, I want to see the face of that man who edited the video for bad purposes.
The video was produced for this charity working on abducted children.
We made this video to help society, but it's being used wrongly and people are dying. We condemn this. Whoever is responsible should be prosecuted.
The makers of this short film say it helped save children's lives in Pakistan. They're now coming to terms with its effects across the border in India. Sikandar Kamani, BBC News, Karachi.
So based on this example, and in fact, there's a Wikipedia page called WhatsApp Murders in India. I applied for a grant from WhatsApp, which is owned by Meta, which also has Facebook and Instagram. And based on the grant, we went to India and created different versions, a text version, an audio version, and a video version of different fake stories, fake news stories that were popular around the time in India. And then we administered that to people in different parts of India. And we found, as we had hypothesized, that when the fake story is told in video form compared to audio or text form, the credibility of the content is that much higher. That is, people believe the video fake much more than they believe audio or text fake. And what's more worrisome is that they're more likely to share that with others through WhatsApp. And this is because, as we discovered in the study, of the phenomenon of seeing is believing. Seeing is believing is the idea that, when you see something, it almost begs for you to trust it because your own eyes cannot deceive you. And this is what we call realism heuristic. If something seems real, then it is credible. So when fake news gets enriched presentation mode from text to audio to video, it results in more realistic approximations of reality, and thereby makes people believe in fake information much more so. So that is one story. There's another story of another heuristic. So that was the realism heuristic. There's another story about machine heuristic that I'd like to share with you. Our mental model of machines is dominated by positive stereotypes. We think of machines as more objective than humans. We think they can perform tasks with greater precisions and that they are more secure. So we did a study where we provided participants with a scenario where they would enter their credit card information to buy a flight ticket between 2 US cities through a chat with Siri or with a human sales agent. And we found, we basically did not do any difference. It was exactly the same conversation. It was either a human agent in one condition or a machine agent in another condition. And that was the only difference. And what did we find? We found that their tendency to give out credit card information was much higher when the agent was a machine compared to when the agent was a human. And so this and several other studies like this in our lab led us to conclude that people have greater trust in a machine agent. They trust machine agents more than human agent, not only when it comes to disclosure of personal information, but also in other domains. This kind of trust that's engendered by a machine is what we call automation bias. And this, again, can have deadly consequences. Some of you might have heard of these Boeing 737 MAX airplanes crashing in recent years. there were two big crashes. And, it was basically a fault of the sensors that were sitting on the aircraft and that were giving faulty, sensor signals to the MCAS system, which pushed the nose down because it was being misled by the sensors. And the pilots didn't know how to, correct it. Pilots were trained for this system with an iPad lesson for just about an hour. So there was very minimal training. And why is this? Because the airlines thought that machines can do a better job than humans. They had over-trusted machines in this case. And this is true even with not just the airline, but also the company that manufactured the aircraft, Boeing, did not think it necessary to train humans. They had so much faith in their machine. And so this kind of bias, this kind of belief in the positive effects of machines can end up killing people, just like the belief in our own eyes, the realism heuristic. So different technological affordances can create different psychological heuristics or trigger different heuristics, like the modality affordance of how video compared to text created the realism heuristic. Similarly, the agency affordance of whether something is a machine as opposed to human can trigger the machine heuristic. So in a model that I published 15 years ago called the main model, I talk about how different affordances of media technologies, modality, agency, interactivity, and navigability affordances, this is what MAIN stands for, can trigger different heuristics, different cognitive shortcuts or mental shortcuts that we have. These are rules of thumb that we have in our head that are triggered by these different affordances, which then shape the way we evaluate the quality of content and also judge that content. And so this is the result of technology shaping the way we evaluate content. And so trust is a psychological reality. We tend to overtrust technology, and we tend to, generally speaking, rely on it more than we probably should, even though it has high error rates. Sometimes when technology goes wrong, sometimes when Netflix does not quite show the movie that we like, we tend to then dismiss the technology altogether and build a kind of an aversion to it, what some people have called algorithmic aversion. And so that leads to undertrust, which is also a problem. What we really need is appropriate trust, not too much trust, not too little trust. What we really need is calibration of trust that strikes a nice middle ground between the two. So a couple of years ago, Vera Liao at Microsoft Research and myself came up with some design suggestions on how to engender responsible trust in AI. And we took a communication perspective based in part on the main model that I was just talking about. We talked about warranted trust. We defined the concept of warranted trustworthiness cues that can lead to warranted trust judgment, as opposed, with respect to the true level of trustworthiness. We want the level of trust to match whatever the system is capable of doing. So for a cue to be warranted, it should satisfy three conditions. These are the three conditions we came up with. We said, first of all, there's a truthfulness condition. It should be presented honestly by the technology creator without any kind of deceptive manipulation. There should be no dark patterns, if you will. And then secondly, it should meet the relevance condition. So the cues should be relevant to evaluation of trustworthiness, to our understanding of the attributes of the system that actually deserve our trust. And then finally, a calibration condition. It should lead to well-calibrated trust judgment by the target users with regard to trustworthiness attributes that it reflects. So it should have a built-in way in which we can calibrate. So they should permit formal analysis of calibration, measuring change in people's behaviors, people's trust-related behaviors and judgments corresponding to manipulated changes in the attributes. So if, in fact, a system becomes less trustworthy, then people should rely on it less. So that kind of calibration should be available. And so the target group, the users, should have the ability and the motivation to perform systematic processing of the information supplied on the interface. And it should not have unfounded trust heuristics. So it should not evoke false heuristics like the ones that I discussed earlier, like realism heuristic or machine heuristic. It should not bank on these heuristics that might sometimes mislead people into believing in false information and trusting it without it being worthy. So in general, we call for expensive trustworthiness cues, whereby, as an industry, it should be pretty expensive for them. There should be governmental or other regulatory expenditure. There should be some cost to industry. They should go through checks and balances, and they should get the housekeeping seal, so to speak, the good housekeeping seal from the government agency or some other policy-making body, policy enforcing body that can make it expensive. Just like when researchers do human subjects research, they seek the approval of the IRB, the Institutional Review Board, to make sure that the research is conducted in an ethical manner. So based on social signaling theory, and which comes from evolution, we do guard against deception by costing the signaler something that would not be afforded to someone who is giving you a product of lesser quality. So signaling is very important, and the main model that I talked about is really the being adapted now to what we call the theory of interactive media effects, where affordances convey cues that signal to users, and the users in turn form cognitive heuristics that shape their perceptions of not only the source, but also the interface and also the content delivered by the interface. And another way in which affordances can help us is by actually acting upon them. If we want to systematically process the information and evaluate the trust characteristics, we should be able to do that by acting on the interface. So this is formalized in the theory of interactive media effects that my students and I came up with some 8 years ago. And this has more recently been applied to the context of human-AI interaction, where we are talking about affordances of AI medium manifesting themselves on the interface or in terms of algorithmic attributes that then trigger cues, which then shape our attitudes and perceptions by triggering cognitive heuristics or mental shortcuts. So this is formalized in an article that appeared 3 years ago in the Journal of Computer-Mediated Communication, and essentially lays out a cue route and an action route. So much of what I've been talking about is the cue route, where we're really talking about visible attributes of an AI, how AI presents itself to the user, and how it can explain itself to the user can trigger positive heuristics and create a better user engagement that is much more calibrated, much more thoughtful. So in our paper that I talked about, which was presented at FACT in Korea, that Vera Liao and I wrote about responsible AI, we do talk about all the different heuristics that might be triggered in ways that can communicate the ability, the benevolence, and the integrity of a system. These are the trustworthiness attributes of a system, and AI-generated content can help trigger certain heuristics that might be helpful in calibrating users' trust. So, for example, if you have provenance transparency, transparency regarding how the training data came about, or if you have transparency relating to governance, then this can trigger different kinds of heuristics. So these are all the different types of heuristics that we are talking about in the context of AI providing cues. AI affordances are plentiful. There are affordances for personalization, conversation, classification, and automation. And depending on the cues that you put on the interface, in personalization, you can communicate the type of algorithm it is, or the type of, in the case of classification, the type of training data. And so you provide cues on the interface. And you also take into account people's prior experience, their privacy concerns, their biases toward algorithms. All of those can also make a difference to how people might engage with the AI system and the degree to which they might trust the AI system. And so putting it all together, AI affordances in the form of interface cues interact with your prior experience to generate the heuristics that can shape your trust. That is the cue route. In terms of the action route, AI can invite users to be a mutual actor. They can help involve you in decision making. So in one of our recent studies from our lab, we looked at content moderation, how collaboration between AI and humans can enhance trust and acceptance of content classification systems. And we applied this model that I talked about, but in the context of content moderation system, where the content moderator was just AI or human, or AI along with human. And then we also provided action possibility. We allowed for interactive transparency. Instead of just simply transparency or no transparency at all, we allowed the user to dictate what kind of keywords to use to decide whether a piece of content is hate speech or not, or to classify whether a piece of content is suicidal ideation or not. And we found several findings, but just to kind of give you a high-level overview, we found that the source of classification affected trust. If it was AI, it triggered a positive machine heuristic, and that triggered more trust. But AI sometimes can also trigger negative machine heuristic, that it lacks the nuance and the human subjectivity to decide on something as sensitive as suicidal ideation or hate speech. And so if it triggered negative machine heuristic, it reduced the trust. When it came to interactive transparency, the key thing that it did is the interactive transparency increased user agency and made users feel that they were a relevant actor in this situation. And that user agency was responsible for higher trust, because users felt that they can provide input on this classification. And so they thought that they can trust it more because of their own involvement. So in this way, you can build human AI collaboration in fruitful ways by having this ideology of social exchange, advancing user interest at minimal cost, and then you can augment each other. AI can augment humans with better decision making, and humans can augment AI by providing their input and having their say, so that it can do a better job the next time it's classifying for users. So this is the way forward for socially responsible trust in AI, is you provide interactivity. Instead of simply explaining, you're also being responsive to user consent, to user feedback, giving more control to user, allowing user to customize and also to correct the algorithm. So it's a two-pronged strategy in some ways. Interface cues, just to summarize, can lead to unfounded trust heuristics, which can lead to overtrust or undertrust, which means you need to have rigorous warranting of cues. The systems need to allow for rigorous warranting of cues by users. And then interactive tools will encourage systematic processing by users by advancing their agency in the face of rising machine agency, because machines increasingly are taking over a lot of decision making. And then it promotes socially responsible AI by emphasizing truthful and warranted communication of AI capabilities, its characteristics, and enabling user collaboration. So in many ways, we are talking about interface cues, triggering trust heuristics toward trust, interactive tools, allowing for systematic processing, and socially responsible AI, building honest communications and encouraging user collaboration, all toward building greater trust and eventually more trustworthy AI systems in our society. With those words, I do thank you for your attention, and will be happy to take questions during the Q&A period and during the panel session that will follow this keynote address. Thank you.